Well, good day to all. Welcome to Fluke Reliability's Best Practice webinar series. Today, the title of our session is What Happens After the Alignment, presented by Mike Ciocys and Chelsea Fiegel. We will begin in just a few more minutes as folks continue to pile in. Talk to you soon. Well, all right, let's get started. Once again, thank you so much for joining us today. You have joined the Fluke Reliability Best Practice webinar series. My name is Dawn Kayada. I am your moderator for today. The session today, we're talking about what happens after the alignment. Our presenters are Mike Ciosis, Chelsea Fiegel. We will meet them a little bit more in detail in one moment. Again, we have some housekeeping items. We will be answering questions as we go along. And so be sure to use the question box in your control panel. You'll see that, and you can separate that if you want it to be off by itself by clicking that square box with the little arrow, and not to be confused with your chat button. So today we'd like to introduce, we have the next slide. Yep, we have Mike Ciosis, who is our Technical Service and Support Manager of the Americas. Mike got his mechanical engineering degree from Temple University. He started with Proof Technic in 2009. Right now, he is leading the technical support team for the Americas from Philadelphia. And he has great experience, many experiences conducting complex alignments, troubleshooting machines, conditions, and also online condition monitoring. He is Cat 3 certified for vibration analysis and condition monitoring. And Mike is quite the source of information, so please, as we go along, ask those questions. And we also have joining us today, Ms. Chelsea Fiegel. Chelsea is the service sales team leader for North America. She did join Proof Technic as well in 2015, so these both come from that side of the business. She is our sales and application engineer. She holds an environmental engineering degree from Penn State. So both of our speakers today live in the Pennsylvania area right now. As you can see, also Chelsea will be moving to Chicago to bring a little more service to the Midwest area, and she has a broad base of expertise in providing reliability solutions through all sorts of industries, including paper, all the way through corrugated to steel and film. So without further ado, I believe we have a poll to kick us off first. So the poll question to get you guys engaged: after aligning new equipment before startup, have plans been made to monitor the asset? Okay, so we're going to launch this, and please, as many of you can, please begin voting, and you can pick one, please. So 100, well, let's see. Yes, assets will now be collected on our vibration routes. What we're doing, we're going to add wireless vibration sensors to the asset right now. Machine is super critical. It is directly wired into the PLC. None of the above options. I do something different. And I don't understand the question. So we've got about 22% of the audience voted so far. I'm going to give it another couple seconds. So please, so that the presenters know, where you stand on some of these things, and definitely can tailor this more toward what your needs are. So, all right, looks like we have people still voting. Thank you so much. And all right, let's close that up and share the results. So we've got, looks like 62% say yes, assets will now be collected on our vibration routes. 6% are adding wireless vibration sensors to the assets right now. 17% machine is super critical, it's wired into my PLC. 15% say none of the above, and 0 don't understand the question. So, Chelsea, Mike, any comments on those numbers? Kind of what you expected?
Kind of what we expected. I think good thing is that everyone understands the question, which is a positive. The routes is definitely the most popular, but it is also interesting to see people doing something different, which is why we put the question up here in the first place. Is that what don't we know? And so we're curious to hear as the presentation goes on what maybe we're talking about aligns or doesn't align with some of the practices by our attendees. So we look forward to getting some feedback on this as we proceed.
Great. So Chelsea, can we see the deck now, I think? And take it away, Mike.
Perfect. So I'll start with the agenda here. Oh, Chelsea, go ahead. Chelsea, it's yours.
Thank you, Mike. So our agenda for today is going to be covering the service element and alignment as a baseline tool. We'll go over planning to monitor your asset condition and trending the parameters, interpreting the data for asset health, and lastly, we'll cover the recurring service elements that we offer that will help you maintain and sustain asset condition. So first, I want to talk about a little bit what alignment is, what we're talking about when we talk about alignment, specifically machine alignment. And we're talking about the orientation and positioning of equipment relative to other equipment in the plant. And there's a couple different types here. We have shafts, cylinders, and plates, and each one of those components will require a different alignment. For example, shafts will need to be collinear and cylinders parallel. There's both absolute and relative that are needed. And just to be clear, when we say absolute, we are referencing exact positioning, so an exact distance between two different pieces of, or two different objects, and relative, which is going to be exact orientation. So in the image on the right-hand side, you can see a scenario where both of these may be required. There are some different components going on here. We have rolls. This is a top-down view of a coating machine. So we have rolls that need to be parallel. We have shafts, probably motors, gearboxes, pumps all over that need to be aligned. And also we need to align, when we align machines, especially new machines, we need to create some kind of datum or reference point, which is typically referred to as the baseline, which is represented by the two dots on the left-hand side. So a lot of different aspects of alignment here and a lot of different methods that we can use to make sure that we are aligning machinery. Here are a couple of the traditional techniques that I'm sure you are all familiar with already. There's a tape measure, plumb bob, precision level, dial indicator, and optics. And all of these pieces of equipment have their own applications. So definitely not that one is better than the other, but some are more precise than others. And again, obviously when cost and user experience comes into play, that will help kind of determine when and where you're going to use these methods. Some of the things to consider right away is that the tape measure and plumb bob, they do have low precision. And optics also require a line of sight. When we talk about precision alignment, there are new tools entering the market, like the laser tracker, like the Paralign that I will get into, which offers you a more precise opportunity to align your machinery. Doing it with the laser tracker, there's a couple different ways you can do it, and I just want to be clear about the difference between a laser tracker and some of the other equipment that's out there. So the laser tracker is unique in that it is able to obtain measurements in all 3 dimensions which is different than traditional methods, which are only able to measure in one-dimensional or along a single plane. So the way the process will work is there's a spherically mounted retroflector, which is known as the SMR, and you're able to sweep the SMR around different objects in space and gather data on those objects. You're not limited to whether it's a piece of framework, whether it's a roll, whether it's the baseline, like I mentioned. The only limiting factor here is that you need the line of sight to the piece of equipment that you're measuring, similarly to how you would need the line of sight with traditional optics, either theodolite or transit. So data points are collected and they're displayed in the corresponding software, which is great because you're able to get a visual representation of the objects in a three-dimensional space that's similar to CAD basically, and you can create CAD drawings of your machinery. And once the coordinate systems are established in the software, then you're able to kind of manipulate the measurement results, and you can use basically any of the data that you've created or collected to see how different components of your machine are aligned, whether to baselines, whether to earth level, whether to, if they're perpendicular to each other, things like that. So the application is really unlimited once you've already collected the data in the software. The Paraline, on the other hand, is a unique piece of equipment that you guys may have used in your plant for roll alignment. And this piece of equipment does not require a line of sight, which is a great advantage relative to the other methods that we've covered. And the Paraline has 3 gyroscopes inside the unit, which are situated in the X, Y, and Z directions, and they're collecting data as the device is swept over top of a roll. Once those data points are collected, the software then will figure out what the center axis of the rolls are, and you're able to very quickly measure and align your rolls in your machine and be able to make corrections to those to make sure that they're parallel and the web is running properly through the machine, so that product is produced with better quality and at faster speeds in some cases. So these gyroscopes that are in there are the same gyroscopes that are used in our military aircraft. And again, and I just want to be clear, this Paraline is only offered as a service from Prutechnic, whereas some of the other methods that I've already covered, you can buy those. You can buy our laser tracker, so you can use them in-house. Or you could always call upon our team to come out with the equipment and perform the service for you. So there's obviously a difference between precision and accuracy, and how I covered some of the traditional alignment methods, they may not be as precise as we need them today. We want our machines to run quicker. We want them to produce product at a much faster rate to meet our customer demands. So it's very important that not only are we aligning the machinery up front, but that we're doing it precisely. And the overall scope of this is to basically create a baseline of data. And with the intention, of course, to track that data over time. And upon initial install, I talk about initial installations just because you get to really put in the certain alignment criteria right up front and vibration right up front and set your reliability process up first thing so that you're able to have a clean baseline and track that over time. But that doesn't mean that if you already have an existing machine, you cannot obviously get started on your reliability journey. It's just doing it right away will allow you to preserve that asset much longer and extend the life cycle. So here's just a quick example of when alignment fails. And obviously, like I said, with precision and accuracy, these things do happen. I even have customers that call up and I'll ask when was the last alignment done, and in some cases they do not know, or the response may be that the alignment wasn't done since the machine was installed to begin with 30 years ago. So it's really important, obviously, that we are aligning our machinery, and there are billions of dollars that are wasted a year due to misalignment of machinery, and losing money is never fun. So I touched a little bit on about why alignment should be done during new installs, and this is really why at the heart of it, right? Because when you do it, you're able to increase the reliability of your assets. You're able to produce better quality and reduce defects, and you're able to increase your run speeds for your machines and decrease power consumption. Proper alignment minimizes waste, downtime, and reduces overall maintenance costs. Mike, over to you.
Thanks, Chelsea. I think the real main takeaway there, especially with all the work that's being done, is having that data, which is kind of the theme of our presentation, and having that as a baseline, having that as something to reference and go back to, is really kind of empowering for the process that happens afterwards. And so we'll kick off this next slide here, Chelsea. And what really happens once you've done the alignment, you've invested all this energy, you've done all this work, you've installed the machine, you've had a crew or your own crew come out and actually do this work. We find that a lot of the next steps don't happen, which is why we're doing this best practice webinar in the first place. And so the idea with all these assets is that you have started them or run them, and now they're running. And do you have data? Do you have information on what is actually going on with these units? And what are you doing about that data? And so kind of our curve here, I mean, sometimes this curve is a little shorter as it is longer. Hopefully it's very long, and you start the machine, it runs for a very long time with no problems. But at some point, ultimately, something does happen. Now, the sooner you get a hold of it, the cost of fixing it or adjusting it or sustaining it is usually typically lower. And so that's why kind of as this curve starts to go toward total failure, typically you're looking at ultimately either you're going to repair a machine or you're going to replace the machine. And replacing is typically more costly than repair. The kind of along the path here, you get a couple options. Some of the first and the most common is to check vibration. Others like oil analysis and wear give you another indicator, infrared and thermography. These are kind of the batch of things that you can use a lot of different tools to collect information with. By the time you get to audible noise or heat, if you can hear, see, or feel the machine kind of going wrong, it's too late. You've gone past the point of repair into some type of crisis management, and you've gone too far, to say the least. Now, some things running to failure is a defined plan. That's fine. If it's defined, it's fine, so that everyone's in agreement of what's going on. But everything else, you should have some type of kind of maintenance strategy. We're going to talk about vibration, but that does not mean that wear debris, oil analysis, IR, ultrasound, that doesn't mean that those things aren't part of your plan. It also could be part of our poll question, that some of the things we listed up there are or weren't listed up there are actually some of the stuff that's being done by the attendants on this webinar. But the big kind of catch-all for a lot of this is vibration. And so once you've installed this machine or you've done an alignment or you've checked it and you're ready to start this up, and you have a baseline kind of data set for its condition upon day one, it's really important to then take that and kind of monitor it as it goes. And so there's a couple options, Chelsea, if you don't mind advancing the slide. There's a couple options on what to do, but the concept is the same. And so just for a brief example here, I have this kind of motor pump in the top left corner, this yellow-blue, and we just kind of did some really simple graphics here. And so on day one, which would be kind of the left-hand side, you have perfect alignment. These two units are sitting in the right space. Their center lines are matching, but you could kind of hypothesize that maybe there's a drip from the ceiling or something is causing some erosion of the base of the motor on the right-hand side. And what's happening over time is that this motor is now starting to move away. It's moving out of alignment. And so there's two kind of main data sets especially with vibration, that kind of help to give you an indication of what's going on. We call it like level 1, level 2 data. Level 1 is like a trend. It's like watching the stock market, kind of going up and down. Level 2 might be these more complex data sets, spectrums, time waveforms, different things like that. Both are empowering. Both should be done. But with level 1 data, this is typically a really good place to start. And so on a day 1, you might be taking some vibration readings. They're very low. But over time, as this deterioration of the foundation is starting to move your machine, you're going to find that as this misalignment starts to set in, the vibration level is going to increase. And what's going to happen is this trend starts to rise. As the problem gets worse, you're going to essentially get to a point where the machine is going to either stop running or destroy some component of itself. And at that point, your vibration level will probably be at its highest. Using the trend, you can make very powerful decisions about what's going on. And so you can see in the second graph here, by the time the trend kind of passes the yellow, you should be out there either checking the alignment, calling Chelsea and her team to have someone come out and take a look at it, or making the correction and fixing the root cause of whatever this water leakage or foundation failure is coming from. And then at some point, that curve should then drive that back down, and then the machine's running again. This scenario kind of shows, if you're not doing anything, where this is going to go. If you're collecting data with some different tools, you might have access to some very specific graphs and data sets. And so like here with the level 2, there's actually some changes in the spectrum here. They're indicating exactly what's going on, what type of misalignment might be occurring, the fact that the misalignment might be leading to another failure that starts to then show up in the graph as well. And so this is what you're trying to kind of put a number to. So once you've kind of aligned all this and you have these assets in the field, do you have a system in place, a plan in place to collect data that gives you this type of information on what to do with your asset? And so let's take a look at some examples. So Chelsea, if you could kick it ahead. So from our poll, it looks like most of the team, and this would align with our understanding as well, they're doing route data collection. Perfectly suitable plan. It works for a lot of assets. It's usually done on a weekly, monthly, maybe a quarterly plan. The timing of your route is really based on how critical the asset is. So if you're doing monthly PM routes, then you're looking at data on a monthly scale, which means on a year you're going to have 12 data points. But you're doing that because you think that the asset, you'll be able to get the asset's health in that time frame, and that time frame will also allow you to have enough time to make a decision about what to do if something goes wrong. And so it's not uncommon that we see this done monthly. We see it quarterly as well, depending on the machine. Route collection is done on very critical machines. It's done on some very more simplistic or maybe less critical machines, but the plan is a sound one. Let's take a look at another option, Chelsea. Yep. For machines that maybe require a little more of overview, we're now starting to talk about putting a sensor on the machine. So you might have something more permanent, like accelerometer. You have some wireless options that can be mounted to the machine as well. You're doing this because you need a little bit more data than what you're getting from the route, probably. And the route you're getting, maybe you're doing a monthly, so you're getting 12 data points a year. Something like this, you're looking at getting a data point maybe every hour, every day. So now we've taken 12 data points a year up to maybe 365 or more. And that gives you a much clearer picture of what's going on. It gives you a much more recent picture of what's going on. And you can make a decision about what to do with the machine at that point. And so this would be, we're starting to go from maybe something that's a little less critical, maybe semi, to critical machines, something that needs I need to know at least during that day, or maybe to the hour, that this thing is actually okay. And so, of course, there's the option to put a sensor on the machine with a wire. The wireless option gives you the flexibility to mount sensors in places that are hard to reach. Or if you have a route program, there's assets that are maybe behind guards, they're up in high places, they're in dangerous zones. Wireless sensors also are very helpful for that. So you can keep people out of harm's way, but still collect the data that you need on those assets. Let's go one more slide, Chelsea, if you don't mind. We'll look at kind of the other part of the polling question is you have some equipment that you need data nearly constantly. So within the second, or I need the ability to see some really complex graphs. Maybe you have some turbo machinery, you have something on a journal bearing, and so you need to have orbits, you need to have some type of high frequency spectrum to see, or long duration time waveforms on different pieces of equipment. This might happen because the speed is changing on the item. This might happen because the load or the condition. To Chelsea's point, in different paper mills, steel mills, you might be running different grades of material, you might be running at different speeds. You might need the flexibility to make some changes on how the data is collected. So like a system like this, an online condition monitoring, something that where the sensors are wired in, the device is wired in, it's going to your PLC, your DCS, and you're pushing information maybe to the system from your own PLC, but you're also then gathering information from the system like this, like the vibration, the temperature, load, speed, phase, pressure, and all that. And so a system like this, I mean, looking at kind of high value, something that maybe is not redundant, you don't have 2 of them or 3 of them, the complexity, talking about just the different operating conditions, and then also mission critical, which kind of can go against those top 3. If you have a little oil pump that supplies some really big piece of equipment, if the oil pump goes down and everything else goes down, it's mission critical. And so it might not be a very high value item, but it still needs constant attention. And so with these 3 concepts, so the route, the wireless, and the online condition monitoring, they all have their place. We're finding more and more, everyone's using everything. And so it's not just one wrench to turn the bolt, it's all the sets of wrenches to turn all the different bolts. And so these different systems are very well suited for the different applications. And so, especially with the alignment, I mean, you have, with what Chelsea was talking about with roll alignment, you have all these rollers, they're all supported by different bearings. They're all driven, some of them might be driven by different pieces of equipment. All of that ties into this holistic kind of understanding of, do I have data on this machine? Do I understand what it's doing? And then what do I do with this data once I have it? Let's take a look at some examples of the data. So we'll kick another slide. Chelsea, please. So this would be an example of some level 2 data, so a spectrum. And depending on the system you're using, this can be very powerful for detecting the asset health. And so once you've done all this pre-work on the alignments, I'm looking at data sets like this to determine, for instance, is the alignment now falling out? As something, maybe I have a looseness that's now contributing to a misalignment. We could talk about all the rollers in that machine. Do I now have a buildup of material in one of the rollers that's now causing an imbalance that then would have to be investigated? All of these issues can then also play into, am I starting to lose mechanical seals? Do I have any issues with the bearings now? I've lost a seal and now I'm losing the grease and now my bearing is starting to fail. And so these technologies are very complementary. I mean, the idea that alignment then can be detected by vibration is not a foreign concept. And so this type of data is very useful. From a service perspective, there's probably a lot of attendees here that have their own team that can look at this data and interpret it and make decisions. It's also not uncommon that there's a lot of people that outsource this. They have professionals that are coming in, maybe doing monthly routes and issuing reports and kind of providing this feedback on what's going on with the machine. This would be, it's either or. If you have the resources to do it, fantastic. If you need to source a resource to do it for you, it's also a very common practice, or just source that expert when you need them. And so you might be good 90% of the time. But on a case where you get a graph that you don't understand, you get an asset where the vibration or the characteristic has changed drastically, it's not a problem then to reach out to an expert to get some second opinions. And so with interpreting this data, you then can take that trend that might be increasing, make a change, bring the trend back down, and extend the life to a condition monitoring strategy is going to ultimately empower you to keep this asset alive and running for a very long time. So, Chelsea, I think I have one more slide. Maybe. No, whole question. So I'll hand this to Dawn.
There we go. Thank you. So the next poll question to the audience, and I'll launch it in a second, but when a fault is found and work needs to be done, how are you handling? And please click as many that apply. So I will launch, and it should be coming at you now. So do you handle it fully in-house by your reliability and maintenance teams? Do we pull in outside contractors for most work? Is it a mix of in-house and contractors? It's complicated, case-by-case basis. And no, I don't believe that no blockers was supposed to be there, but you can ignore that one. So we have about 30-some%. Great, thank you, everyone. Everybody's kind of chiming in now. We'll give it about another 4 seconds. Awesome. Thank you, everyone. So what we're seeing is 58%, Mike, handle fully in-house. 13% we pull in outside contractors. 55% say it's a mix of in-house and contractors. And 24% is complicated. Comments on that?
What a spread. So I think it's complicated does not surprise me, hence why we put it up there. The amount of in-house is good. I think that really kind of shows that there's a lot of companies taking this seriously. Reliability is a big part of operate the business, and so it's easy to bring it in-house. You're talking about not only like having a team, hiring a team, or training up a team to do that type of work, but also the equipment that's necessary to do it. Having everything kind of a mix, or pulling in some contractors to help. I see that. I mean, we see that a lot because it's hard to bring the expertise in-house, and so I think this is an interesting breakdown. I think we could actually probably take a lot of kind of what this looks like and apply it to some of our findings with not only our sales data, but also with just our customer conversations as well. So this is very interesting.
Yes, thank you. Next slide.
I think it goes to Chelsea, I believe.
All right.
Perfect. Thanks, guys. So there are some different options, whether you're looking to go take your program in-house or completely outsource, or perhaps a mixture of the two, right? And in some of those cases where it's base by base. Just to kind of sum everything up here, some of the services that we do offer in addition to the alignment services would be the vibration analysis, as Mike covered. These are integral parts of any condition-based and predictive maintenance program. We have oil analysis offerings that conduct early bearing wear, and ultrasound testing, which would be for detecting hidden leaks in air and gas pressure pipes and vacuum systems. So something like the ultrasound may be a great complementary product or even service that you can bolt on, whether you're buying some tools in upcoming months or if you're scheduling some service work as well. Options are pretty flexible and customizable. You may find that if you're just starting your vibration journey, it doesn't make sense right now to completely go in-house, just because maybe you don't have the manpower or the resources to do so, or the time to do so. So we offer pretty flexible options to either collect data in-house or outsource it completely. And then again, with the data, because it's two-part, either analyzing in-house or outsourcing to us to analyze the data for you. We offer vibration training, that would be ISO CAT certified training. We also have training on all of our products, so keep an eye out for those. I believe we offer those online and in your plant. And we also have adaptable support as your plant needs. Some of the services, again, from the beginning that we offer roll alignment with the Paraline, geometrical alignment with the Faro laser tracker, and of course shaft alignment with our shaft alignment tools, the Rotalign, the Optalign, etc. Here's a quick snapshot of our portfolio, just to kind of bring everything together so that you can see the complete view of Fluke Reliability and its operating entities. There is a plethora of stuff here, so I know it's pretty packed, and Mike and I threw a lot of stuff at you today, but if you guys have any questions, feel free, and we'll be.
Oh, Chelsea, sounds like we're losing you a little bit there. There we go.
Can you hear me?
Yeah, we can hear you. So, wow, you guys ran through that information pretty quickly. Thank you so much. Give us a nice foundation. One question that has come in from one of our audience members is, how do you do an alignment on many rollers using the Paraline? So I don't know how deeply you want to go into that, or, contact later. That's up to you guys.
Sure, yeah, I can briefly provide an answer. So as long as you can still hear me, okay. Yeah. Great. So doing the alignment for a lot of roles with the Paraline, it's kind of the whole purpose of having the Paraline as an option here, because of its speed and its ability to not need a line of sight to measure rollers. It really stands out in the field. So anywhere, I mean, depending on industry, of course, and how wide the rolls, how big the rolls are, you can measure anywhere from 50 to 80 rolls in the paper industry to over 300 in the converting industry in a single day. So there's a lot of there's a huge advantage, I would say, to using the Paraline, and not only that, then tying in the laser tracker as well. So with the Paraline, you're able to collect data quickly for parallelism of the rollers. And then you want to add in also that absolute distancing aspect, right, that we're talking about for alignment. And you're able to do that with the laser tracker. So combining those two technologies together creates basically an untouchable opportunity to create precision alignment in your plant for every single component of your machine. So I'll kind of leave it at that, and if there's more questions about that, I'll go further.
Sure. Nope, that's great. And maybe, Chelsea, if you go back one slide with the listing of all the services, maybe it'll help kind of make sense of these and services and products and so forth. So there is another question. We talked a lot about data points, data collection. And the analysis service, there's a question of clarity. How do you report the findings? Do you use an online dashboard? And maybe talk a little bit more about what exact points we're reporting on.
Would that be for alignment or vibration?
It just says data collection for your analysis service. It doesn't say either one. Just speak to both.
I'm going to assume that's
I cover both. I've covered, Chelsea, I cover from the alignment side first. I'll do the vibration side.
Okay. For alignment, there's a couple different ways that the information is portrayed. For Paraline specifically, it's going to be with the corresponding software on a laptop, so it's communicated via Bluetooth. The client that schedules a service would receive a two-dimensional readout of the vertical and horizontal offsets for each roll at the end of the service. And then a follow-up report is sent a few days later showing how the rolls moved right from initial position to end position. And also with the Faro, just because of the Faro laser tracker and its more cumbersome software, it's able to, it depends on kind of how the client wants to view the data that was collected. So there's very many different ways, like I said, that you can utilize that software. But it really just depends on what you're looking to analyze there. So I'll kick it over to you, Mike, to talk about vibration data.
Yes, the vibration data side, we've had we can provide this in many different ways. It's also displayed in many different ways. There's a couple dashboard systems, so digital dashboards, where you're looking at the asset. You might see some trends, an actual kind of maybe live readout from what's going on. I think the definition of reporting kind of gets turned into two things: actually being handed a physical report, and also actually maybe visualizing on a dashboard that also gets construed as reporting. I'd say that both. For me, I understand both definitions. I think that we treat them as such as well. And so there's dashboard systems. There's also the ability with different devices to push data to a dashboard that, like the customer might have, SCADA system or something like that. And so there's a lot of open protocols with Modbus, MQTT, Profinet, different systems that we can take data and then push it to a DCS so that you can see this data kind of on whatever system might be already existing. A lot of times the limitation there with that type of reporting is that those complex level 2 graphs, they don't really move through those data streams. They're too complex. So you're looking at integers, just numbers. So you might see that maybe the overall vibration went up, speed went down, temperature went up or down. And so those integer numbers can move between the systems, no problem. But if you're looking at maybe like a hot shot report, like something went wrong and you had someone come in and look at it kind of very rapidly, those are typically like a paper report or a digital report. You might see some level 2 data with some markers on it. So it's showing maybe which frequencies are being highlighted and what they indicate the failure might be. So whether you have maybe an imbalance, a looseness, maybe your bearing frequencies in there that are now present because the bearing is starting to fail. Those type of reports are a little more maybe formal because of how they have to be written and the amount of detail that might be there. And so I would say there's kind of the two types of reporting. Either is some type of dashboard system, which can be either static or live, and then something more complex, which is with the level 2 data that has to be more explained and highlighted in different ways. And so it's not uncommon that, like, I mean, it actually might be even necessary that to detect the fault, I'm pulling data from sensors that are all over the machine, so that each sensor is seeing from a different perspective. Maybe even a sensor on another machine is helpful because it might be telling me something about maybe the fault is so bad that it's actually present on another machine as well. And so that type of data typically has to be kind of written out. And then the frequency of something like that would be discussed with the customer.
Great, I appreciate that. And another question that came in is, I see all these other options, but I'm not seeing thermography on the slide. Is there any reason why?
I'll take this one. I mean, the focus of we had a time frame, so I think we kept it to within vibration. And thermography is definitely a technique and science that needs to be deployed for reliability. And we didn't cover it here. We'd be happy to do a presentation that maybe solely looks at that, because there is a lot of content there as well. And so, but we just didn't cover it in the scope of this presentation. But we could in the future.
No, great. Thanks for that question, Helmy. I kind of responded that way, and that's a webinar all on its own, I think, right?
I would think so, yes.
So great. I have another one. This is fantastic. Thank you, Mike and Chelsea. We have still about 12 minutes left. But is there a recommended alignment schedule for specific types of machinery? Have you guys, while you're out there, is there anything like a certain asset that you can say, yes, we need to do this every 6 months, or any type of best practices that you've seen, repeat and where we can say, yeah.
Yeah, sure. I can answer from my perspective and experience in the field. Usually talk about this in terms of industry type. So whereas you might have more often shutdowns or shorter shutdowns more often in paper and steel industries, you might have, let's say, a corrugator, for example, will shut down every weekend, or film can kind of shut down on a dime. So it really just depends on the industry. But
That's
I
helpful.
lost my train of thought now. Hold on. Okay, so it depends on, I'm just going to tie in the vibration stuff to this, right? Because if you're already monitoring your machines, it's great because it can indicate if an alignment is needed. So that would be best case scenario. Worst case scenario is that you kind of run until you see maybe issues with your product or issues with a reoccurring failure in one of your assets. That might be an indication, right, that you would do it. But if things are all running well and fine, I always recommend probably annually for most industries, because you never know if you're doing a lot of roll change outs, if you're having a component change out, or you're doing an overhaul or replacing some kind of part of the machine. It's definitely critical to do that alignment right up front. So it really just depends. And it depends on tolerance. So if you have a much tighter tolerance, then you would probably be doing alignments more often than not. Whereas in film, for example, in bag making, where tolerance is not as tight, you could get away with having rolls maybe not aligned so often, and really see no problem in the product that you're making. So it really just depends, I would say, Dawn. But maybe Mike, if you have a different perspective on that, I'd be happy to turn it over to you and hear what you have to say.
The only thing I would hammer home is so it's been maybe it's been a little while since I've done some of these alignments, but I know with just thinking back, the number of times that myself got called out because it was the customer that recognized there was a problem with the product. And so like it was that worst case scenario that you're highlighting, that like by the time it was not proactive, it was not preventative, it was reactionary, and it was crisis. And so there was something wrong, and even worst case was that the product that they were making was being sent to another person and they rejected it. And so it was at that stage that they go, that we have a problem. And so I think pushing that home is that like we're talking, they might have had some data and they didn't make the right decisions. They might not have had data at all, so they're kind of flying blind. But I can just recall the numerous times that that's happened. I think that's a bad place to be. It's kind of, it doesn't have to be that way. There's a lot of different technologies out there right now that can empower you across all different price points and functionalities and skill sets that really make that type, it should be obsolete, that kind of issue mostly, like that. You shouldn't be waiting for someone to reject your product before you start to analyze what's going on with your machine. And so I leave that there, of course, but I agree with Chelsea's logic on all of that.
Yep, that's great. Thank you. So one more. And so we talked a little bit about critical assets, less critical. How do I decide what machine is critical versus less critical, and where to start? Who wants that one?
I'll give it to Chelsea first.
All right, Chelsea first.
All right, Mike, thanks for putting me on the spot. When it comes to alignment, I would always suggest, at least from what I hear from my clients, is that we're going to be looking to align the machines that make the most money, really, right? So it really just depends on how often you're running the machine, and I guess just how often you're running it and how much money the machine is making for you would probably decide which one's most critical and which one you want to spend the most time on during your shutdowns. That's what I would say.
I'll add to that is that I think we kind of see two different things that happen. First is that someone looks at the machine that costs the most money to keep running, or is generating the most money, to Chelsea's point. Or the second one is the one that's causing those problems. Is that someone goes, I don't know what's going on with this thing, and I need to start collecting data on it to see what's going on. And so I would say primarily a lot of the discussions start on those two kind of polar ends of the spectrum, and then kind of works its way inland as it's like, well, what else can we look at? And what else then? Like once we've kind of got the bad actors or the expensive thing, like what else in the middle can we expand this project to cover? And so I don't think that's a bad practice, though it's maybe a little short-sighted, because it's like, well, you have to make a decision on what is the most expensive or the money generating machine, and you can make mistakes and miss some stuff that maybe is not directly in your field of view, but it's also critical. So, but you have to start somewhere, and if the bad actor is causing you a lot of pain that day, you should pay attention to that. If you're being kind of mandated to deploy condition monitoring in some sense, and you don't know where to start, and this is just a new project for you, I would say then you start with the thing that would cost you the most to repair. And so it depends on kind of the maybe how you got into the conversation in the first place. If some piece of equipment crashed and caused just a very painful moment for you and the team, that's probably where you start first. If it's coming kind of from the top down, or being initiated by the reliability team, they're like, hey, we should take on some new technology to empower us with different data sets, then you kind of maybe start with saying what's working right now and how do we make sure it stays that way. So that would be my feedback.
Yeah. And that's all really good feedback. And I believe that there's also experts within Fluke Reliability that we have an asset criticality service that we can also deploy on site and so forth, that we can, talk through those, determine those goals, right? What's the organization's goals? How did we get here? Like Mike and Chelsea both said. So one more, I keep saying that, but they keep coming in. So thanks again, audience. What is the best argument to provide to operations that the equipment should be stopped after alignment to perform a new check? Yeah.
I won't put you on the spot this time, Chelsea, unless you have something to contribute immediately.
That's okay. Say what you're thinking, and I'll chime in then.
So I think, if you need confidence, or if you need some type of justification to say that something has changed or something's up or something, this I think is where it's the power of statistics. Really, it's the data. And so if you are looking at something and something just isn't right, if you're looking at one data point, like for instance with this route collection, if you collected one data point on the first month of your route collection, and you look at it and you say, I don't know what this means, but it doesn't look good. That's a really hard place to stand and defend the position from with one data point. If you have many, so like if you're trending data more constantly, you have data points that are on the minutes or the hour, and you now all of a sudden over the last 7 days, you have 7 times 24 hours. I mean, you have hundreds of data points to then look at this and say, no, our trend is increasing. Coupled this with maybe some contextual information that maybe if it's a paper mill or something that's creating a product, you say, hey, our trend is increasing and our yield is going down. Something is wrong. This is where it's very data. And so I would say that if and it's not uncommon, unfortunately, that a lot of people call us and they say, I have 2 graphs. I don't know what they mean. I say, you need more data. To collect more. We don't know if you have the most accurate data set. We don't know if you're collecting it the right way, but we can use statistics to help us empower that. So that would be my comment: is collect more, and that'll help you stand in a really good spot to make good decisions.
Yeah, that's good advice, and we just keep hearing that. The more that we can paint that picture for operations leadership, you can't deny it, right?
If you want to take it from outside of this reliability and maintenance perspective, would you buy a stock? How would you buy a stock? Would you wait to see if the price stays low? Is it going up? Is it going down? You're going to look at data to try to make that decision, because it's like, hey, I'm not going to buy this when it's been sitting at the highest level for a long time. And you don't want to look at 1 day's worth of data. You want many months. And so like that's analogous to the same situation. Is that, has it been running this way for just today, or has it been running this way for a long time? And so I would say that the mentality is the same. You would want more data if you're going to buy something, and the team's going to want more data if they're going to stop the machine to take a look at it.
Absolutely. Great closing thought there. Chelsea, anything as we wrap up here, any closing thoughts from you?
Yeah, just one. I see also in this latest question, it seems like maybe it's coming from a reliability focused point of view, and they need something to kind of convince their operations team to stop the machine, to do the alignment, and to check, verify where the alignment is at. And that's really difficult, when, especially when you have machines that need to run 24/7. You know, kind of like we talked about, it's so hard to schedule downtime, and it's really kind of that fight, right, between the scheduling team and the maintenance team. And so I think the main things to focus on there would be, right, safety and cost too, right? Because if you install a new piece of machinery or replace a roll or anything like that, and you're changing the components of the machine and you're not doing an alignment check and you're not staying down long enough to verify where things have been placed, well, then you open up the opportunity, right, the door to more risk, essentially, where things may, things you might have thought they were installed right and they aren't, and then things break, they cost more money, people are there fixing them, maybe there's safety concerns around that because it was a really hard job to begin with. So I would recommend when trying to have that argument with operations is just really information and knowledge, and just explaining, the importance of doing these kinds of things up front. So, and I hope what we talked about today kind of covered some of that.
Yep, that was fantastic. Thank you, Chelsea. And if you can advance to the next slide, guys, we are actually out of time. And so we're going to talk about the next webinar coming up on October 6th. Will be with Jake Moselwitz. He's presented for us at Accelerate, and his discussion will be of why we can't proceduralize everything. We're humans, and we really go into this adaptable system versus mechanistic, and it's really a great way of looking at human behavior. So I encourage you to join us on that one. It should be interesting. So, and then again, please, as we close out today's session, you will see the survey come through. Please take some time, fill that out. There's an area for you to put in areas that you'd like to be covered. For example, the thermography piece that we talked about, put that in the comments there. And again, if you want a certificate, please also identify that. If you'd like to speak to one of our experts, fantastic, put that in there as well. You will also receive a follow-up with the link to the recording and the PDF. You also have the opportunity to request demos, so use your resources. And thank you so much to our presenters today, Chelsea and Mike. Great information. I've learned a lot. I hope you guys have out there as well. So we'll see you again October 6th. Thanks so much. Bye-bye.